Hey, this week I'm going to do something a little bit different. One of the guys in the comments has suggested that I might want to do a comparison of positive to negative ground. And so I thought, I don't have anything else going on this week, so hey, that's a great idea. So thanks, Peter, for that suggestion. And without further ado, we'll get on with it. I'll be comparing these two Nortons right here. Sorry about the Yamaha playing monkey in the middle there, but anyway, this one right here, I geared up with negative ground. That's my latest Norton, by the way. This one over here, I've had since 1989, and that one's a positive ground. So, what's the difference between the two of them? Well, one's got a negative ground, the other one's got a positive ground, really. But anyway, let's go over to the bench and we'll talk a little bit more about this sort of thing. To begin with, positive ground, negative ground. Negative ground simply means that the negative post of the battery is connected to the ground on the machine, and positive is just the opposite. The positive post of the battery is connected to the ground of the machine. Why would there be any difference? Well, like before the Second World War, a lot of these old bikes, like this one here, were negative ground. After the Second World War, they started going back towards positive ground with the British motorcycle industry, and honestly, I don't know why. I have looked up this thing on the internet for a couple of years now, and I haven't come up with a really definitive answer other than conformity. Everybody was trying to conform to one standard or another around those times, and that's the closest answer I can come to it. But let's just try to understand a little tiny bit about how the electrical system, or the charging system at least, works on these old machines. And we'll start with, first I'm going to tell you, this thing here, this was my version of using the standard equipment, the rectifier and the Zener diode, to make a a negative ground system on a positive ground bike. And that worked quite well. You can see this is a piece of 3/8 inch insulator block underneath. I think that's that phenolic resin or something. But anyway, that was riveted to the fender of the bike to insulate this part from the rest of it, because this part here is now positive, right? And this did work. The only reason I changed it was it's a little bit dangerous, because if you opened up the seat on the bike, then everything here was all connected to the live side of the battery. So if you touch that anywhere on that surface of this heat sink or anything, you would automatically blow a fuse, right? But anyway, don't do this. It was just an experiment that I did on my part. I ended up fitting one of these on that particular bike, and it works perfectly well, and you don't need to worry about blowing fuses when you use those things. But anyway, this right here, if you don't know what that is, if you're dealing with British bikes, that's a bridge rectifier. What it is basically 4 diodes arranged like that. You have AC coming in on one side and DC comes out on the other. So on these 2 posts right here is where the AC from your generator, or your alternator, I should say, would be hooked up. It doesn't matter which wire goes where, because it's AC. It doesn't matter. DC comes out here and here. So, what's this thing? That's another magic little device. That's your Zener diode. That is what amounts to a voltage regulator on these bikes. It's actually an electronic unit, right? And it's electronics basically. My father used to teach electronics and navigational aids in trade school, but I could have learned a lot more from him than I did about electronics. But I was more interested in electrical and mechanical stuff. So sorry, Dad, I didn't really care how TVs and radars worked all that much. But anyway, he did help me build a radio once, but I wish I still had it. Anyway, the way these Zener diodes work is I like to think of them as a dam. Now this structure here would be the dam. Over here would be the reservoir. As the reservoir fills up with water, it reaches the top of the dam and spills over the top and goes down the river, right? So if you think about the Zener diode this way, as the voltage increases instead of the water level, the voltage increases, it reaches a point where it spills past the Zener diode and gets spilt to the frame, basically. So it's a simple electronic affair, and that's basically how it works. But anyway, I'm going to set that aside for now because it's an experiment that I did and it worked, but it's not something I would recommend you to do because, like I say, this whole heat sink is live, and if you touch it against like if you're fiddling around with wrenches or screwdrivers under your bike seat, there's a good chance you're going to hit that and you'll blow the damn fuses. So yeah, don't do that unless you like playing with stuff and doing little experiments around the shop. That's what you do when you're retired, by the way, or I used to do that kind of stuff too before I was retired. This is what most of us are getting now to replace the old rectifier and the Zener. You can buy these online now. You can buy these little tiny bridge rectifiers. They come in various different wattages, and if you get a high enough wattage one, they will work just as well as these. And I'm pretty sure if you looked around an electrical supplier, you could probably find a negative ground Zener diode. But let's not go into that because most of us are using these things. You can get these directly from China. They're exactly the same as the ones you get from other suppliers, but they're about half the price. Anyway, a bunch of electronics in there. I don't know how they work. It's basically little integrated circuits and stuff, but it rectifies the voltage from the alternator, turns it into DC, and it regulates it somehow or other. I suspect it might be something similar to a Zener diode in that electronic gizmo somewhere, but they're really simple. You got two wires that are yellow coming off, and most of them are made like this. If you have two wires that are the same color, these are the ones that connect to your alternator. They almost always come with instructions, so follow the instructions. They quite often come with instructions for positive ground or negative ground systems, whichever you want to use, right? But in this case, the black lead is going to be negative, and the red lead will be positive. Now, if you were worried about keeping, a bike positive ground like it was originally made, then you would use that red lead to go to ground and feed your battery and the rest of the system with this darker lead here. Some are black, some are brown, depending on the manufacturer. But these are a good option. The only thing I don't really like about them is they're not like the old mechanical voltage regulators. You can't clean up a set of points and get them working again. When they fail, you throw them away and you replace them. But it's, as you can see, it's not a big deal to replace them. Usually you mount them with two little bolts to with the frame or a fender or something solid, and it's just a matter of changing clips on the wires. I usually keep a couple of these around the shop just in case I do get one in that's failed. But it's seldom that they do fail anyways. But okay, so if you want to switch around to positive ground to negative ground and vice versa, well, what are you going to do? let's go have a look at the Triumph, because that's easy to look under the seat and you can see what's under there quite easily. So let's have a look in here. Now if you look down in there, there's the regulator rectifier. This one happens to be a titanium unit. It doesn't really matter much. But if you look carefully, you'll see the red wire coming out of there. Connects to that bolt right there that grounds to the frame. So that tells you right away that this is a positive ground unit. The negative lead comes up here. It's a brown wire in this case, and joins into the wiring harness to feed the battery and the rest of the system. So if you wanted to change that around, the first thing you got to do is disconnect the battery. You don't want to go monkeying around with anything that's still got the battery connected to it when you're doing something like this. But all you would have to do is change that red lead for that brown one. Just swap them over. Then when you put your battery back in, you're going to hook the battery up so that ground is now negative if you do that, right? Right now, on the way this bike is set up now, positive on the battery goes to ground. But like I said, if you wanted to switch it around, go negative ground, you switch it around that way. There's a few other things you might need to do. You would need to swap the leads under the ammeter, because when you switch it around, the ammeter will be getting the voltage going through it in the opposite direction. So it'll read wrong. It'll still work, but it won't read properly. Like instead of reading a charge, you would read a discharge, you know, if the bike is working right. So what else? If you were running electronic ignition, you would want to change the wires around on the power box. If you, for example, if you were running Boyer or Branson, you'd want to change the red wire from the ground to the supply, and you'd want to change the supply to the ground. So the white wire would go to ground and the red wire would be your power supply. For conformity's sake, you might want to swap your coils around too. I mean, by coils, I mean the primary side of the coils, where the power goes in. You'd have the negative side of the coil going down to the ignition points or the pickups or whatever. Anyhow, it's not a difficult job to switch over. You just got to be careful what you're doing and that sort of thing. Make sure your fuse is in before you hook your battery back up in case you made a mistake or anything like that. But it's pretty straightforward. It's not a hard job. But anyway, so the question remains, which is better, positive ground or negative ground? Frankly, performance-wise, I don't think there's any difference at all, and I haven't read anything that makes any sense that would indicate anything different. But there is one thing, and I'm going to show it to you now. LEDs. That is a valid reason for switching over to negative ground. You have all kinds of choices. All these bulbs are 12 volt H4 bulbs that will go in an H4 headlight reflector. So, and plus you have tail light bulbs, you can get instrument bulbs. Yes, you can get positive ground LEDs as well, but you have a much broader choice, a much larger selection if you're going with negative ground. So why did they go from positive back to negative ground? Now, I think Triumph did that in 1979. So if you're playing with a 1979 bike, just remember that they're negative ground. They came that way, right? But anyhow, like I said, as far as an advantage to swapping over to negative ground, I think that's the only advantage that I can think of. Like I've said before, I said I've looked for years on the internet and asked people, and I never really got a definitive answer of any kind about why positive ground is any better than negative ground or vice versa. But in this case, if you want to use negative ground LEDs, that's why. Gives you a whole different option of, that's just for headlights, and the thing is, there's all kinds of them out there. Tail light, something to replace an 1157 bulb. There's dozens of different types out there that are very inexpensive. You can buy the expensive positive ground units that go in some bikes. They're over 120 bucks, I think, for those, just for replacing tail light. But if you could go to Princess Auto or Harbor Freight or something like that and pay, $5 for an LED bulb that will just go right into your system, well, why wouldn't you? So anyway, I think that pretty much concludes my little positive negative ground thing here. I hope you got something out of it. I don't know if I was very clear on anything or not, but positive ground, negative ground, flip a coin. Doesn't really matter unless you want to go LED. And if you want to switch over at any time, if you have one of these units in your bike, it's just a matter of swapping wires around, changing the posts on your battery around, and flipping the two wires on your alternator. Alternator on your ammeter. Yeah. So anyhow, thanks for watching. Peter, thanks for the suggestion. I really appreciate it. And be good to each other, and see you next time.